it's been kind of a while between videos, but um, it's unavoidable. So I apologize, but we're gonna still, you know, as always, tick 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 on. Okay, all right. So now we gotta understand something. Okay, we're plugging switches in. All right, and in the background, Spanning Tree is doing his job. It's a protocol that it's invisible to the eye. Okay, all right, unless we do certain show commands to actually figure out what's going on. All right, now if we were going to actually take a look at the data going from switch to switch, okay, all right, if you're curious on how we look at the data, okay, that would be a program called Wireshark, okay, or any TCP dump protocol or any type of third-party application that is meant to read headers and data going out of a network card, okay, and coming in, all right. We would notice this struggle or desire to be the root bridge, okay, all right, and everyone's trying to be the root bridge, okay. Everyone is sending out all this data, okay? But once the root bridge is accepted and everybody agrees, okay, all right, these BPTUs that are out to that are actually being flooded by every switch until the root bridge is decided, okay, after that, everybody stops talking, okay? And at that point, the root bridge is the only one sending out BPTUs, okay? The only time that other non-root bridges will send a BPTU is when there is a topology change, okay, in the topology, meaning a link goes down, you shut down a port, you cut a cable, okay, which is pretty much a link going down, right? All right, okay, now, a topology change notification, all right, you gotta understand, remember we have our root ports. All those root ports on every switch is the shortest path to the root port. So, think about this. You got your designating ports, okay? On the other side of those ports are either gonna be root ports or blocking ports, right? You got your root bridge, okay, which all those ports are going to be designated and forwarding, okay? All right. Now, the interesting thing is the only time another switch will send a BPTU, okay, which they'll send it out the root port, because think about it, all right, you are eliminating loops. So I'm only going to have one port that is effectively able to transmit data in order for it to get somewhere. And the only way for us to happen is through the root port. Okay, think about it. All right, everything else is blocking. Everything else is designating, but on the other side is blocking. Okay, all right. So now topology change happens. Non-root bridge switch sends out a topology change. It sends it out the root port because it needs to get that to the actual root bridge. Okay, all right, and all the switches that gets these topology change notifications are going to forward it out the root port to get that information to the root bridge. Okay, now, okay, you're not going to transit every switch. Okay, all right, because let's say this switch here on the left here, its root port is going up to here as this is the root bridge up here. Okay, this device over here does not get that that topology change notification. All right, but that's the whole thing, because once the bridge gets the topology change notification, its job is to send that TCN packet down to every other switch within the topology. Okay, all right, okay. Now, technically, you're going. It's going to come down and it's going to have a TCN flag that is set to 1. Now, we've never really took a look at the data. That part's okay. We'll eventually get to that, and you understand what I'm talking about. All right. The flag tells the switch to shorten their aging times. to the forwarding delay, which I don't think we discussed that, have we? Okay, which that's my apologies because that's my mess up. So if the aging time is 300 seconds, we're going to change it down to 15. Okay, why? Because we want all that information flushed out as fast as possible so we can actually re-establish a new topology coming in. Okay, all right. This will actually prevent MAC table corruption. Okay, and think about this. You got a MAC address over here. You got one over here. Okay, there's not one there anymore. This can get corrupted doing a topology change. Okay, because what was allowed on that particular port with the link going down, we might not have access to those MAC addresses anymore, and we're sending data to a location that is no longer valid. Okay, so this is why we would change the aging delay. Okay, now, and of course, any active MACs will remain in the table. All right, TCNs are not sent on ports that are configured with port fast. Now, remember what we talked about, that annoying delay from amber to green ports. Okay, all right. This is Spanning Tree going through its stages and not allowing that port to forward any data for 30 plus seconds. Okay? All right, now that is because it is going through, paying attention, waiting for BBTUs, paying attention to whether it's hooked up to a PC, while it's hooked up to another switch, which that's the reality of it. It wants to make sure it's not hooked up to another switch. Okay, and we're not going to just forward packets without running the protocol. Okay. Now, man, I said all that real fast. Okay, so now, if your port is configured as port fast, what you are genuinely doing is eliminating that delay. Take a picture now, or picture this. Your PC goes to boot. During that boot process, it goes out and it says, hey, I'm looking for an IP address and looking for a DHCP server to respond to that. Okay? All right, and bear with me while I peel up these nice little tiny oranges that I got. All right, now, if that port is not set to port fast, okay, by the time it goes into green status, okay, out of amber, it has taken too long and you will get a 169 address. And if you've never realized that before, when you get a 169 address, that's TCP/IP telling you, we tried to get an IP address, no DHCP servers responded, so we're going to give you this 169 address so your PCs can still communicate on the network with these set of IP, IP addresses. Nobody ever uses them. I've never used them. And if I was going to use it, I wouldn't use the 169 address. I would just set up my own IP addresses and put them in manually. All right, so now, so that means configuring port fast on a port allows you to immediately, when you plug in, initializes a port and allows you to forward. Okay, meaning that during that time frame, all your PCs should be set up to port fast. All your printers or your servers, blah 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 blah, because they're not switches. Okay, so that delay is not necessary. So what we're doing is we're turning off Spanning Tree on the ports that we are plugging in devices in, like servers, printers, PCs, blah blah blah. Okay. Now, let me take a breather here. Last thing. Direct topology changes is when a direct link failure occurs, even you shutting down a port manually or administratively. Okay? Indirect topology changes is when communication has failed on up status links. This could be a firewall or other types of filtering. Okay? Let me reread that. Indirect changes is when communication, and you know what's funny? I'm the one that wrote this. Has failed. Okay. You know, I'm not sure why I did that. About the firewall or other types of filtering. The other types of filtering is going to be BBDU filter. Okay, and there's a way of doing that, and that particular filtering could literally cause you to have loops. Okay, especially if you filter BBDUs on a block link, allowing that link to become active again. You have now put a loop back in your network. Okay, I'm not sure why firewall was in there, but nonetheless, okay, I'm not saying that you can't do that, but it's just one of those things that I'm not sure why I put that there. All right, so insignificant topology changes. Okay, imagine having a PC boot and shut off, causing a topology change. Okay, now keep in mind, guys, you're turning it on, turn it off, turn it on, turn it off. So, and they're unplugging the blink, plugging it in on their PC. You don't have port fast configured on that port, which you should. Okay? What you're going to be doing is signaling consistently on and off TCN packets to go out. Okay? And being sent to the root. And then the root's going to send those TCNs out to all the other switches in the topology. All right? Eating up bandwidth. Okay? One of the reasons why port fast should be on there. Okay? All right. MAC agent is dropped to the foreign delay value. Use port fast on edge ports. Blah 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 blah. Okay, so now this is why. Now keep in mind when we talk about edge devices. Okay, you have a switch in your topology. Your domain goes as far as to the edge. Okay, so think of a switch as an extension of your network. So, you take your PC, you plug it into your switch, you have extended your edge of the network from that switch port out to your PC. And now your PC is now the edge instead of the switch port itself. Does that make sense? Okay? So, on the edge of our network, okay, because I want you to think about this. If you plug in a switch into a switch, you have expanded that switch into another switch, which every time you create more links into those ports or plug them in, you are expanding your edge. Okay? So you have adding another 24 ports is giving you a expansion of your edge of your network. Okay? All right, but edge devices where they can't go any further past that device should be set to what? Port fast. Okay? Not switches. Okay? All right, now. Okay. There is one more thing that I want to talk about, which is trunking your switches and setting those trunk links from Spanning Tree's perspective to port fast. So, it's not an edge. However, the links between one switch and the other, we don't really want to have a delay. So, our trunk links will have port fast on it. Okay? Alright? If you choose, you don't have to do this. Okay? You don't have to do this. So now, let's talk about our roles. Our roles of each one of our ports is Spanning Tree is a root port, a designated port, an alternate port, which is giving you an alternate path if one of the other link dies, and a backup. Okay. Now the backup is there if there is multiple ports, okay, in a shared environment, meaning that we will actually have to have our switch plugged into a hub. And you know what's funny? I don't have to buy another hub before we can even do this lab, because I don't even know if I still have it. If I did have it, I don't know what the hell is that. Okay. All right. So now, those are our roles. Okay. All right. Those are just telling you what that role of that port is. Obviously, root port are always going to be forwarding. Designated ports are always going to be forwarding, okay? Excuse me. Okay, so now, those are our roles. Let's talk about our states, okay? We have a blocking state, okay? No traffic is moving. No traffic is transitioning. No traffic is egressing or ingressing. Okay, no traffic coming in, none going out. Now, that's blocking. Plain and simple. Listening. No MAC addresses are learned. Okay. Stale MAC addresses are removed, meaning that if there are MAC addresses on that port, during the listening stages, they are removed. Remember that amber light? During that amber light, we are going through our listening and our learning stages. Okay? Our learning stage, okay, MAC addresses are learned, but still no traffic is moved. Okay? For your listening stage, we got 15 seconds. For your learning stages, by default, we have 15 seconds. Okay? All right? When we do our lab, I'm going to show you those stages, even though I believe one of our videos we've already covered that, watching it go through. Oh, packet tracer. We were going through packet tracer. We saw it going through listening and learning. Okay? As a matter of fact, why not? Yeah. Okay, come on. Jeez. All right. Boom. Let's get our crossover cable here. Boom. Okay. Okay, so now okay, notice that this state right here is listening. Now it's learning. Okay? And once it turns to green, now it's forwarding. Okay? All right? That's why all the times before we got to this section on the training that we had to wait before those ports went to green. Okay? Now, forwarding, obviously, the MACs are learned, and now traffic is finally transitioning. Okay? All right? This stops loops from happening during that time. During the listening learning stages, we are listening to BPDUs, and we're running the topology in the protocol in the background. Okay, making sure that at no given stages of our network are we going to be forwarding while loops are possible in our network. Okay. All right. A disabled port that does not participate in Spanning Tree because the port is shut down, no link on the port, no Spanning Tree incident running on the port. That's possible. Okay? All right? All right? By default, it's always going to be running. All right? Now, after a port initializes, it begins the blocking state. So, not no loops can occur. All right. Only BPDUs are allowed to receive during the blocking stage. Ports are put in standby to stop loops enter blocking stages. Okay. When you learn this, for some reason, when you're reading the documentation, sometimes you get the idea that listening, learning, and forwarding are the only stages, but we got a blocking stage as well. Okay? Ports are moved from blocking to listening, allows to receive and send BPDUs. During this stage, the port is allowed to become a root or designated port. This is because the port is allowed to send BPDUs to advertise itself. Okay? I don't know why I put that there. All right? But nonetheless, all right, if the root or designated status is lost, the port will return back to blocking and start the stages all over again. Okay? Ports are moved into learning after the forward delay of listening. BPDUs are still sending and receiving. The port can now learn. And I'm going to stop right there. Okay? The reason why I'm going to stop right there is because do you see how deep this goes? Okay? All right? Understanding this is necessary, but me reading it off the screen does nothing. Okay? That's why we're stopping. Okay? Go as deep as you want with this technology, as deep as you want. Okay? What you'll learn throughout your time and throughout your career, that you can learn something better than anybody else. Okay? But you might not even touch it in your entire time at your job. Okay? All right? Part of networking is creating procedures and processes that every engineer follows. So we don't have to worry about having issues like this. Okay? Now, true story. Doing a network refresh for one of my contracts, there were so many closets, there were so many switches, so many VLANs, okay? And I had asked the question to my technical lead about Spanning Tree. And because that individual had no, knowledge, and you'll find that lots of times people are in positions that they don't belong in. Oh, well, okay, you deal with it. It was ignored, okay, until Spanning Tree got capped out, okay? And what happened was once it got capped out, because every platform has a certain amount of instances of Spanning Tree, it is allowed to run. Hit that limit, and you'll find out very harshly when your network comes to a halt. So now your core switches are not literally hitting its limit, but it's shutting down every uplink to every switch in your entire campus. Yeah, it's that serious. Okay? And when you're sitting on there talking to Cisco TAC, and you just happen to think, Cisco, could this be a Spanning Tree issue? I come to find out it is. All right. This gives you an understanding that knowing about this technology and just ignoring it is a fool's decision. And I'm not kidding. Okay? All right? It will cause you to have a very bad day. And I'm talking about every uplink to your core switches just stops, shuts down. Okay? All right? So, be careful when you decide that you're having thousands and thousands of VLANs. Make sure you understand what your limitations of Spanning Tree really is as far as how many instances you're allowed to run on that core switch. Okay? Alright, so we're going to stop this video right here. As you notice, I'm doing something a little different this time. Instead of going into deep dives of all the technology, we're going to be doing that stuff later on. But in reality, we're just trying to get an understanding of what is needed in order for you to consider yourself a CCNA from a perspective of being a CCNA. Okay? All right, so now, be strong, be determined, be Cisco.